Next, let's move on to the next property, fifth one, which is time reversal. Okay, so this is just an extension of the previous property. Okay, so let x of t equal to, let x of t has x of j omega as the Fourier transform. Okay, then again I define a new signal as x1 of t, which is equal to x of minus t. This fellow will have x of minus j omega as the Fourier transform. Okay, so if you rotate the signal in time domain, you should rotate the signal in frequency domain. Okay, so that's simple. This is similar to what we have seen in Fourier series also, right? If you rotate the signal in time domain by 180 degrees, in frequency domain also you have to rotate the function by 180 degrees. Okay, so we will take the help of previous result to prove this. Okay, so from previous property, or we'll say from time scaling property, so what did we get from time scaling property? We know that x of at is will have what as Fourier transform? 1 by mod a, x of j omega by a as the Fourier transform. What happens if a is negative? Okay, if a equal to negative in the sense minus 1. Okay, so if a equal to minus 1, we get, okay, what do we get here? X of minus t will have 1 by modulus of minus 1, x of j omega by minus 1, so which is same as x of minus j omega. So that completes the proof. Why modulus of minus 1 is 1, j omega by minus 1 can be written as minus j omega. So if you rotate the signal in time domain, you have to rotate the function in frequency domain. Okay, so that is simple. Now let us take a few examples. Okay, so first one, let x of t equal to e power minus at u of t. Okay, so this fellow has, what is the Fourier transform? You remember, 1 by a plus j omega as the Fourier transform. Okay, so what is the assumption here? We assume a is greater than 0. Okay, question is find, okay, before I'll write down this little bit below, find CTFT of x1 of t, which is nothing but x of minus t. Okay, so that is the question. So before we write this, let us try to plot this signal. So x of t will have what as Fourier transform? Sorry, x of t, how does the plot of x of t look? That is e power minus at u of t. The plot will look like this. Why? Because a is greater than 0. And what is the equation of this curve? It is e power minus at with amplitude 1. So we want to find the Fourier transform of x1 of t, which is equal to x of minus t, but this should be equal to how much here? X of t e power minus at u of t. So x of minus t should be e power at u of minus t. Is it okay? But still a is greater than 0. Keep that in mind. So x of minus t means wherever there is t, you have to replace with minus t. So a is not going to change. So you'll get e power at u of minus t. So the correspond, let's plot the signal and then find the Fourier transform. So definitely, because u of minus t is there, the plot exists only from minus infinity to 0. And what is the equation of this curve? It is e power at. So what will happen to the corresponding Fourier transform? That would be x1 of j omega. Correct. According to the property, x of minus t will have what as Fourier transform here? That fellow will have x of minus j omega, which should be equal to x of j omega is how much? 1 by a plus j omega. So definitely it will have, wherever there is omega, replace with minus omega. You will get 1 by A minus j omega as the Fourier transform. You remember these signals here. This is the first example which we have seen, and this is the second example we have seen. Okay, but what did we do? We have directly got the Fourier transforms from the analysis equation. Okay, so you can get the equation of the second signal from first signal itself by using time reversal property. Okay.